Hey everybody, welcome back to another session for the NCCER CSST. We're going to go ahead and kick it off. We're going to kick off this evening at module 75211, which is confined space. It's going to be page 11.1. We are actually still in the process of uploading the one from last week, module 10. We went a little long on it, so we're doing some editing to it. Should have it up in just the next couple of days, folks, okay? Just to let you know. But we're going to go ahead and kick it off this evening. We're going to go ahead and cover module 11, and then we're also going to I believe we're going to be covering module 12 as well after the break, which is safety meetings. Okay, so that's our plan to get through both of those this evening. So let's go ahead and talk about it, folks. Okay, and remember this: anytime we're talking about confined space, we're talking about there's definitely a big difference, or at least a legal difference, between confined space and a permit required confined space. The biggest issue and the biggest challenge between the two is going to be that there's going to be a significant risk with a permit confined space. There's going to be a much greater risk. And also with a permit required confined space, we have a legal obligation to have a rescue team available. Not necessarily on site, preferably on site, but at a minimum available, okay? So let's go ahead and do this, folks. Let's go ahead and kick off. I'm at 11.2, and let's talk about atmospheric hazards. One of the greatest or the greatest risk with confined space will be atmospheric hazards, folks. Okay, so that's why first of all, it's one of the easiest things to control often or detect because of the evolution of the multi-gas meter. So therefore, with the evolution of the multi-gas meter, it does make it a lot easier for us to be able to have a safe entry and then maintain safe entry as well in order to monitor, either periodically monitor or continuously monitor the air quality conditions. So let's talk about a few things. You'll see there on 2.0.0, atmospheric hazards, right, being one of the most common hazards in confined spaces and also one of the most deadly. So what happens? Well, we may have too little oxygen, right? We may have an inerted atmosphere or an oxygen deficient atmosphere. That's the greatest risk. Second of all, we may have an explosivity or a flammability risk due to vapors, due to dust. Easiest way to explain that is our LEL and our UEL, and I'll show you an illustration of that this evening as well from when we did the safety orientation book a few months ago. And third of all is toxic gases. It could be gases that could possibly poisonous and or push out our breathable oxygen as well. Okay, so the biggest thing we want to remember is that no one should be allowed to enter confined space until we've done some testing. Now, we may have tested and determined that that confined space is just a confined space and that it's not a permit required confined space because there is no significant risk of a atmospheric hazard or any other significant hazard. And we'll talk about that in just a moment, folks, okay? I'm gonna get us through this one first section, and then I'm gonna go to a worksheet that we normally use during our training. If you want me to email it to you, just shoot me an email after the course, and I'm happy to email a PDF of it as well to you, okay? So let's talk about atmospheric hazards, right? Okay, or atmospheric contaminants. So we have three great risks. Like I said, the first risk is going to be oxygen, oxygen deficient, or the atmosphere being inerted, basically not enough oxygen for us to sustain either life or quality of life. Second of all, like we said, would be LEL on UEL, which is our explosivity and our flammability levels. And then the third, like we said, is toxins. And now we're talking about any gas that may either rob our oxygen, but more probable that it's going to poison us, whether it be short term and either incapacitate us or kill us, or long term where it may become a chronic illness as opposed to acute illness down the road. So let's go ahead and we're going to go ahead and define about a handful of contaminants here, 6 of them to be exact. And one of the main things that you'll see is that we often use the words fumes and vapors interchangeably, but there is a difference in them, okay? So let's go ahead and talk about all 6 differences. First of all, we're looking at dust, right? What are we talking about with dust? We're looking at small particles that are generated by crushing solids, right? Where do we often get dust? Well, we could get dust from metal shavings, or from tooling and machining with metals. We could get it from coal. We can get it from wood. We can get it from concrete. We can get it from food processing also. Things like sugarcane, let's say, for a perfect example. Sugarcane is a really good example of one as well. Okay, or wheat. So just some cotton dust as well. So just some examples of different dust that we may be exposed to that may be a respiratory issue, but more importantly, or I'm sorry, not more importantly, but equally as important, could be a flammability or could be an explosivity risk. Then we talk about fumes. And what's the definition of a fume? Well, they're small particles that are created by the condensation from vapors. Okay, and then they often are include volatile metals. So when we're talking about volatile metals, what are we talking about? Let me give you some examples. Welding fumes is a perfect example, right? When we have burning metals, let's say lead fumes, or copper, or nickel. Okay, stainless steel, hexchrome hazards, right? So these are, you often may hear illnesses like metal fume fever, let's say, right? So fumes that are actually toxic to employees or to workers, and like I said, primarily it comes from metals that are burning. Okay, but it will be that they do become particles, and it's often from the condensation, like I said, of that vapor state. And then we also have mist. What are we talking about? Suspended liquid particles. Right now, we're talking about liquefied form, in the form of condensation from gases and liquids that are dispersed with the area. Smoke, basically an aerosol mixture from the incomplete combustion. So, example of this would be smoke would be maybe what comes out of our tailpipe from a vehicle, right? When a train burns coal or a machine burns coal, let's say, it could also be from a fire as well. Okay, so we have smoke. So those are all different examples of when we may have smoke hazards that we may be exposed to. In addition to that, now we're at vapors. And what are we talking about now? Now we're talking about that hazard being in a gaseous form of materials, that normally it's from liquids or solids at room temperature. So a good way that I can explain vapors would be from maybe chemicals that we leave open, right? Or let's say if we're pumping gasoline or we have a gas can. Those are perfect examples of vapors that we may be exposed to. Some may be some may be a respiratory issue to us, and some might be a flammability issue to us, or they may be both. And then gases, materials, uh, materials that do not exist, right, as solids or liquids, okay, at room temperature, like carbon monoxide, ammonia, carbon dioxide. Those are different gases that we would be exposed to. Okay, so that's just a brief synopsis of 6 different air contaminants, atmospheric contaminants that we may be exposed to. Okay. All right, great. So let me go ahead and bring you to this workshop. Okay, I'm sorry, to this worksheet that we often use, and I'm gonna go ahead and blow it up. So let's see. There you go. If you have any problems seeing that, please just shoot me a text, and what I'll do is I'll enlarge it like this. But I'd rather keep the whole sheet if possible. It's a little bit easier to use, okay, and it's a little bit easier to explain while we have everything on the same screen, folks. Okay. So there you go. I've enlarged it to keep everything on. All right, first of all, let's talk about a confined space, right? We often talk about confined space, permit required confined space, permit required confined space. But let's break down the OSHA definition of what a confined space is. Okay, if you look on your bottom left-hand corner, you'll see it's got to meet all 3 of these in order to be a confined space. It's got to be large enough for an employee to bodily enter and fully perform their duties, right? It's got to be not designed for continuous occupancy by the employee, and it has to have limited means of entry and exit. Now, when they say limited, when the OSHA standard says limited, we're not talking about number of entrances. We're not talking about like one entrance, let's say, into an ammo room, or one entrance into, let's say, a a bag house or something. Okay, so what we're talking about when we say limited is we're talking about how an employee or a worker must contort their body in order to enter a space. So I'm talking about things like having to climb ladders up and down, having to um, scoot in and out, go through a manway in and out. And I'm going to show you some examples of these in a second, folks. Okay. Um, uh, Very steep sloping floors or inward converging walls. Those are all examples of converging floors, excuse me, of limited accessibility. Okay. Fixed ladders, not either fixed ladders or portable ladders, not fixed stairwells, but fixed ladders. We're also looking at limited means of entry and exit. Okay, so it's got to have all three of those in order to be a confined space. And then OSHA says that if it has all three and it is now determined that it's a confined space, now we got to determine if it's a permit required confined space. So what are we going to do? Well, let's look at our list on the left hand side now. You might see my mouse moving, folks. If you do, don't worry about it. I'm just having to move it. I've got a window that you don't see that shows attendance messages going back and forth and all the controls. Okay, so sorry. I hope it doesn't distract you. All right, so now let's talk about what makes that confined space a permit required confined space. Now let's say that the employer has identified the confined spaces that are in the workplace. So now that the employer has identified the confined spaces that are in the workplace, now that now the employer also has to go ahead and determine if that space is a regular confined space or if it's a permit required confined space. If it's a permit required confined space, it's going to have to be identified by do not enter signs, confined space, authorized workers only, signs like that we normally see. I'll bring us to Google in just a moment. We'll see some of the confined spaces that are on this list on your upper left-hand corner of this worksheet. And I'll show you some examples of some of these of what we're talking about. Okay. All right, so if that confined space has at least one or more of these characteristics, and then we must reclassify it or classify it as a permit required confined space. And the only way we can declassify it or reclassify it going back to a non-permitted confined space is that we'll have to start removing hazards excuse me, I'm sorry, folks, I keep on doing that by methods of things like lockout, tagout, ventilation, okay, and different controls like that in order to reduce the risk, so that we can declassify it or reclassify it back into a non-permit required confined space. Okay, and we're going to talk about how that often happens in a refinery or in industrial work, especially. Okay, so if it has the three characteristics on your left, and it has at least one or more on the right, which means it contains or has the potential to contain a hazardous atmosphere. So again, could there be a potentially oxygen deficient atmosphere? Could there be a potentially oxygen enriched atmosphere? Could there be a material that could potentially engulf us if somebody enters? Let me give you an example of that, right? Might be like sunflower seeds or grain in a silo. Okay, maybe a decontamination pit where there may be liquids and or maybe sludge. It could also be inside of a trench if it were to potentially collapse, if it didn't have a protective system or an adequate protective system on it, sloping, benching, or shielding. Also, it has an internal configuration that might cause an entrant to be trapped or asphyxiated by inward converging walls. Basically, the walls start tightening up. So if you're looking at it from, like, let's say a side profile, inside the tank, the walls would look more like maybe like an ice cream cone going down, or like a V going down, okay, where somebody maybe get pinned towards the bottom. And then the last one is any other significant or recognized hazard. Could be electrical hazards, could be lockout tagout failure, could be moving parts, could be maybe items or pieces of equipment that could become newly actuated, okay, and crush, pinch, or shear someone, for example. So it could be a wildlife. It could be that we find a massive swarm of bees or wasps in there, especially if employees are potentially uh, allergic to it. Okay, so like I said, if it meets the three on the left, it's a confined space. If it meets at least one or more on the right, and now it's a permit required confined space. So let's use some examples now. If you look up here in your top left, items like this, right? Marine vessels and barges, stationary tanks, mobile tanks. I'll show you some pictures of these in just a moment. Rail cars, excavations, blenders or pits, silos, hoppers, elevators, kilns, manholes, basins, sewer lines, pipes, lift stations, maybe diked areas around the tank. Those are all examples, and often general industry, and then some maritime. And then in the middle, you'll see more maritime vessels that in the vessels themselves. They could be either they're determined and they're identified as either enclosed spaces or confined spaces. Enclosed spaces are kind of treated almost like a non-permit required confined space, and then confined spaces are treated more like a permit required confined space in in shipyard or in maritime applications. So enclosed spaces are going to include the cargo holds, the tanks, the quarters, machines, boiler spaces, items like that. And then usually wherever there's been any type of product being held or significant machinery or moving parts, things like a double bottom tank, a wing tank, a cofferdam would be where there would be a significant risk in maritime. So therefore, those would be considered confined spaces as opposed to enclosed spaces. And the reason that they're identified differently than they are in most other situations from just confined space and permit required confined space is because every shipyard is required to have a rescue team on site. So therefore, just about every entry would pretty much be considered permit required. So they just go with the confined space standard, knowing that the rescue team has to already be available. Okay. So the biggest thing, like I said, the biggest thing here, folks, the difference between confined space and permit required confined space is the difference of a rescue team. Okay. Now, this is one of those chapters, folks, just so you know, we're going to be skipping a lot of pages in this chapter, a lot of sections, just because we tend to train a lot off of this sheet, off of this worksheet that you see. Okay. So let me show you some examples of these. Give me one moment. Let me pull up some examples, and then we're going to go into air quality and talk about it. Okay. Um, Before we move on, let me show you this, folks. This right here that you see, the responsibilities of the duties of an authorized entrant, attendant, and supervisor. All right. And right here where you see the criteria for the employer when they're selecting a rescue team, all these four right here, let me show you where they come from, okay? There is a new confined space construction standard that came out about a year and a half ago, but the majority of this information is actually found in the OSHA standards in general industry. So if you're not familiar with it, let me show you where it is so you can kind of find it when you need it, okay? This is what I'm doing. I'm going to do OSHA 1910.146, which that is the confined space entry standard for construction. So let me show you where it is so that you can see it just in case you want to be able to find it yourself, okay? Okay, so right here, permit required confined space, 1910-146. This is the OSHA standard in general industry. There are three different confined space standards now in OSHA. There's the general industry, which applies to everyone. And then there's one also for construction that gives us just a little bit less uh, responsibility or requirements, but very, very little. I really just follow the 1910 because it's a little more stringent, unless the client chooses not to. And then you have one for maritime as well, okay, for shipyards. So and that one's confined in enclosed spaces. So let me go here and I'm going to look up the word. I'm doing Control F, folks, And right here, you'll see my little find menu came up. It's kind of small for you to see, especially if you're on a mobile device. But I'm doing Control F, and I'm looking up the word duties, DUTIES. And as you notice, there's 13 references to the word duty. And I'm actually going to the one where the sections are. I'm kind of just cruising through because I kind of know where I'm going with this already. And here you go, folks. There you go. There are the duties right here of an authorized entrant. Know the hazards, how to properly use the equipment, communicate with the attendant, alert the attendant whenever there's a recognized hazard or a condition that's prohibited. Exit the space as quickly as possible whenever ordered to do so. And then recognizing the signs and symptoms of any hazards. So here's an example. So let me go ahead and show you. All right. Let me go back to that worksheet. And the worksheet here, as you see, there are your duties of the entrance. Okay. So that's where we got this information from. Okay. And then if you come back in and let's say we go to the duties of the attendant. Here you go, duties of the attendant now. And the same thing, it's all the responsibilities here. And then they're also on that sheet. And then last of all, it's going to be duties of the supervisor. Let me see where those are. Here you go, duties of the entry supervisor, 146J. Okay, and these will also follow the worksheet. Okay, and then of course there's some information in there if your employer is going to have a rescue team or your facility is going to have a rescue team. Here's the criteria on what you must do in order to build and select and build a rescue team. Okay, so this is where all these duties come from. Like I said, right now is from that standard. Okay, all right, so let me go back to that standard now, and I'm going to show you where the construction standard is as well. So this is the general industry standard, 1910-146. Like we said, let me go to the top. There you go, 1910-146. And all it did was Google 1910-146. But I can do this, folks. I can do 1910-146, and I can do confined space, okay? I'm telling it I want general industry confined space, and there you go. It's the second one right there, okay? So what I'm doing is I'm actually doing I'm doing a search in Google, but I'm basically telling it and directing it where I want to go. So I basically wanted to go in this particular situation, I wanted to go specifically to general industry. So now this is what I'm going to do. Now I'm going to come in here and I'm going to type in 1926 confined space. And now I'm going to bring us to the 1200 standards, 1926 1200, Cell Part AA. This is the new confined space standard for construction that I was telling you about that was released a year and a half ago. Okay. And if you ever look at this document, it pretty much almost mirrors the general industry, except there are just a few more little leeways in it. One of the big ones is that permits can be kept open a little bit longer. Also, uh, a responsibility of all contractors and attendants to be able to speak to one another at all levels. But folks, I'm telling you, even in a general industry environment, we're supposed to be contacting anyone else who's going to be in that confined space to make sure that somebody's not doing something where they're going to build up some type of vapors or fumes that may become flammable or toxic. And then another group's going to be in there, let's say, doing work where they may fall victim or ill to a toxic environment, or they may be doing a hot work process to where they could significantly injure themselves or kill themselves or anyone else. Okay. So that's your construction one right here, 1926 1200. And then let me just bring you to the maritime really quickly, folks. All I'm doing is OSHA confined space. I'm going to type in maritime. And then the ones that I'm looking for are the 1915 standards, which here you go. Let's see. Here you go, folks. Subpart B. All I did was do my control find again right here in the upper right hand corner. Like I said previously, if anybody's on a, whenever you work on a PC, laptop, or desktop, you can do Control F and it'll pull up a find window for you. If you're on a MacBook, which you can use Command F and it'll open that same window for you. Okay. Okay, so here's your confined space standard here for construction now. And it'll go in and it'll start getting into the standard number and what the meat of the standard is. Okay. So you got that there. And let me show you one last thing as a resource right now, folks. You can also come up here to uh, eTools. Let's see. And this isn't actually where I was going, but I'm gonna actually come back to it. Let's see the OSHA eTools. Okay, and then in here you can start getting into atmospheric hazards. You start getting into lower explosive limits. Okay, items like that. Okay, now let me go to and right here, you see confined spaces right here. Okay, I'm in the eTools tab. It'll go in and start telling me what certain standards are the laws if you want to look it up that way, and then it will also right here, electronic permitting system. And basically it gives you information. It'll give you different requirements, information on confined space and how to be compliant and protect the employees that we serve as well. Okay. All right. So you have all that there, folks. And then let me go to one more thing right here. I'm going to type in the word publications. Go to OSHA publications. And I'm here. I'm going to do Control F. And I'm going to do confined space. And there you go, folks. So look here, what I'm looking at is different fact sheets and different publications. Okay, and fishing vessels, traditional confined spaces. This is a booklet, and you'll see that this has got the majority of the training material that we're looked at right now in the standard. This is a good, very good booklet, folks. Okay, let me see. I thought it was like 30 pages. Let's see, 19 pages. Okay, and then it'll go in there. It'll start giving you the standard, the decision tree of how you can determine if it's a confined space or a permit required confined space, what we have to have in our written programs, okay, controlling the hazards, equipment for safe entry, what we need, detection of hazardous environments, right, detector. Also talks about entry permits, worker training, terminating permits as well, the duties of authorized entrance, attendants, and supervisors. Okay. And then what we need to do in emergency procedures, it goes on to tell us about our safety data sheets, okay, and it goes on to give us some consultation advice too. So that's the 19-page publication, just in case you want to take a peek at that. That's a great resource. And then you'll have some of these, which are like OSHA quick cards and fact sheets, and which will just give us a little bit more information. Usually these are like 1 or 2 pages. These are really great, folks. If you're doing, let's say, safety, if you're responsible to do a safety meeting, right? A 5, 10-minute, 15-minute safety meeting, or even when you do it with us, when you do your evaluation prior to the end of on test day. Uh, you can feel free to pull one out of here. We usually do one with scaffolds, but we will let anybody do whatever topic that they want to do. Okay, if it's a topic you're comfortable with, great. If it's a topic that you're not comfortable with and you want to tackle it, hey, even better. Okay, so so let's go ahead and let me show you some pictures of what certain confined spaces may look like. And give me one moment. I'm going to open up another PowerPoint. I'm sorry about that. I need to figure out which one it is, folks. So let me just bear with me for a moment, okay? Okay, here we go right here. Okay, so let me just show you an example of certain confined spaces in our workplace. And anybody out there that I know if you're on your smart device, I know it's really hard to kind of chime in because you have to go away from your screen. So don't worry about it. But if anybody's in there and you're on the live session tonight, just feel free to add whatever comments you'd like. Okay, you're more than welcome to. Let's see. Oh, I was already in there. So good. Great. Okay, so let's go ahead and go from here, folks. Okay. Alrighty. So different catch basins, okay, could be a confined space, right? Remember, let's think about let's talk about what the let's talk about what the three criteria are, right? Large enough to bodily enter and do our job, not made for continuous occupancy, and limited means of entry and exit. Those are the three. Those are the three characteristics that it's got to be a confined space. And we're about to talk about that because I'm going to give you a little caveat to that in just a second. Inside of a pipe or a manhole. Okay. So let me ask you, folks. I know a few of you out there, can type. Anybody know? And if you can, if not, don't worry about it. Anybody know why manhole covers up here? Here you see your manhole. You see your cover. Anybody know why manhole covers are round? Or anybody want to take a stab at it? 5, 4, 3, 2. Yep, because the pipe's around. Yeah, that's what I would say too. No, that's not it. That's what I would say also. So let me tell you why they're round. I saw it on a show one day, one of those shows like How It's Made or something like that, and I was just so amazed how we just miss it every time we see it. We don't realize how things are engineered to protect us. The manhole cover is round, so no matter how it gets dislodged in whatever shape, however you twist it or turn it, in all theory, as long as the cover is not cracked or deformed, and as long as this ring, the bezel here, is not cracked or deformed, there's no way, it's almost virtually impossible, and it shouldn't happen, to where this cover should fall in this hole. So basically what it is it prevents struck by hazards from striking employees or workers or anyone else who may be down below. Okay. And it also prevents people from walking on top of them or traveling over them, and they actually becoming dislodged. You may have noticed some when you have like a clean out drain or culvert or something like that. Often they're rectangular, and those often get dislodged and they fall in, right? In a little 2 foot deep, 3 foot deep, little catch basin or something. So that's a perfect example of what we're trying to prevent, and here in this particular situation. Okay. All right, great. So let's go ahead and move on. Also, it could be silos like this. Okay, so now we're talking about silos. Silos are fixed ladders like this, like you see here. Okay, that's going to be a confined space if it's a fixed ladder. And then this is your bird well cage. For anybody who's not familiar with your bird well cage, they used to run from 30 feet to 20, and then from 20 down to where your walking surface was. We used to be able to free climb 20 feet. Now OSHA says that this birdwell cage has to come down all the way down to 8 feet, and it can possibly come down to 7 feet but no lower. Okay, so the bottom of this bird cage now, from its walking surface, well, nowadays should never be less than 7 feet from the walking surface and no more than 8 feet. Just enough for an employee to get in and travel up. Okay. So as many of us know, some of these tanks like this, right, above ground storage tanks, are often about 42 to 52 feet in the air. So what happens is, just so you know, OSHA mandates when it is a fixed ladder like this, the longest we can climb before getting to a work platform, a rest platform, which is like what you see here, the most we can climb is 30 feet. And then we must get to a rest platform. We normally interchange there, and then we keep on going up. Okay. So we go up no more than 30, over, and then up no more than 30, and then maybe over again, and vice versa, over. Okay. That's how fixed ladders often work. Okay. And then down here, you'll also see your manways, right, to get into the tank. And then here you see also your dike walls. We may have a dike made out of concrete or cinder blocks sealed like this. and it will normally be 110% of the largest tank in that dike or in that berm. And berm is just like a little levee, okay? So all I'm talking about is kind of like a little hill going all the way around, usually made out of dirt and grass. And what it's for is the same thing, so that people, so that if the largest tank either floods out or fails or whatever the case is, and there's a rainstorm or whatever the case is, that it should capture 110% of its largest tank in that berm or dike. Okay. Okay, so let's go ahead and keep moving. And then inside of an excavation, and here you see these employees that are inside of a trench box, right? That's what gives them their protection against cave-ins. Once we put a protection against cave-in, if this area is no longer an atmospheric hazard, it could very well be reclassified to a non-permit required confined space, but it would still be a confined space because they're using a ladder to access in and out. So therefore, a ladder is limited means of entry and exit. Okay. All right, good. And then it could be things like this, like a pits or vats, large enough for employees to get in. It could be a hopper. And I'm not just talking about the whole platform here. I'm talking about it could be maybe one of the units in here. It could be something, let's say this could be a conveyor line, a tube, or it could be a kiln if it turns and heats and dries. So so it could be something like a piping like that, a kiln, like I said, like that. It could be maybe a unit, a chiller unit. Okay, it could be something like this, where you see like almost like I can't remember what it's called right now. It's almost like a funnel system, right? Is basically what it is. So there you have inward converging walls. So inside of here would be a confined space. Inside of here, here, here. Inside of the tubes would be. Okay, and any equipment that's not normally that's not traditional means of entry and exit. Okay. Also, inside of these above ground storage tanks like this, like fuel cells as well, if these are large enough to open a hatch and for us to get in and do a repair or to clean, and then they're also a confined space, they're probably going to be a permit required confined space because of atmospheric hazards, primarily oxygen level and LEL, lower explosive levels as well. Okay. Sorry about that. I forgot I had one of our guys in the tank. So it could be something like this, like processing tanks as well. And this is what happens, folks. Getting inside of this manway here, that could wind up being a confined space because they're having to configure their body. That's limited means of entry and exit. And by climbing this fixed stairs here, these fixed stairs here also is going to be a confined space because of the fixed stairs. Now, if we have it to where we put a stairwell, right, a spiral staircase, I thought I had one. If we had one where we put a spiral staircase there, and then that would be traditional means of entry and exit. So therefore, it would no longer be a confined space. If it's not a confined space, it would no longer be a permit required confined space. However, it doesn't make the area any less hazardous. Okay, so let me show you what I'm talking about. So let me sift through. Okay, I don't have one here. Let me go to another picture on the internet. So we have a processing tank like that, and then with a fixed ladder. Let me go to Google and let's do above ground storage tanks. Okay, so let me go to images. Okay, folks, so let's say above ground storage tanks, and let me use an example for one. Let's say here, folks. Here's a perfect example. So as you notice in this photo, these have a spiral staircase, right? But however, we know others have a fixed ladder, like the one we just looked at, or let me just pull up another one, I guess. Here you go again, spiral staircase. Okay, those would not be a confined space. However, OSHA says that you should still treat them as if they were confined space because the area is no less hazardous. There's still the risk of oxygen deficiency. There's still the risk of explosivity. Okay, and I'm looking for one more, folks, just to see if fixed ladder. If not, I'll go back to the PowerPoint on it. Here you go. There you go. Fixed ladder there. Okay. So these are now not a confined space. These are also a confined space because of fixed ladder. That means limited means of entry and exit. Okay. So let me tell you, you may find this more and more, and we're starting to see this a good bit out there. When there's limited means for to put spiral staircases in, or let's say if they're watching cost, what'll wind up happening is something like this. I'm trying to see if I can get to a picture of one. Let's say, let me use an example. Let's say that, let's just go with this picture, okay? Let's just go with it here. Let's say for some reason this tank on the outside has a spiral case, and let's say the fourth tank on the outside has a spiral case. Tank 2 and 3 here, they have a fixed ladder. Let's say they didn't invest the money to go ahead and do the retrofitting on them, right? If you do 4 and you do 1 and they're interconnected at the top with a catwalk all the way across, well, in those situations, none of the 4 would still be a confined space because you can exit one of these 2 tanks by going to 4, or you can exit one of these 2 tanks by going to 1. Okay, so the spiral case doesn't even have to be on that tank, as long as you can hop from tank to tank on, let's say, a catwalk, right, with your mid rail, top rail in place, and then now it still would not be a a confined space. Okay. And then what you're starting to notice more and more now is things like this, where we're starting to put guardrail systems all along the top as well. Okay, so you're starting to see that we're doing more and more fall prevention, or more and more fall restraint from the top of tanks as well. Okay, so just to kind of give you a heads up as to what's going on there. All right, so let's go ahead and keep moving, folks. Okay, let's say, let me give you an example. Let's talk about confined space and accessibility one more time. I'm going to use an illustration of a tank that I built in here. It's not the greatest work in the world, but I think it'll get our point done. And let's say, let me go to it. 2 last things, right? Manhole, and then also the back of uh, haulers as well. If somebody can fit in there, and then it's going to be a confined space. All right, so let's go with this photo here. Let's say this is our above ground storage tank, folks. And let's say we have a round manway, right? So just give me 1 second. Let me just go ahead and put manway in for us. Okay, let's say we have a manway like this, right? And let's say there's our large enough to bodily enter and do our job, right? Now we're looking at um, no, we don't have, we have limited means of entry and exit because we're going through a manway and not made for continuous occupancy. So it meets the 3 criteria of being a confined space, right? Okay, so now let's say we take that same tank, and let me open this up a little bit more. And let's say we take that same exact tank, and now we went ahead and cut a whole panel out of it, right? We cut a whole panel of 2 sheets out of it with a torch cutter, and then we removed them. Now we can bring in a backhoe, a trackhoe, a forklift, right? Multiple employees can walk in and out at one time. Well, it's still large enough to bodily enter and do our job. It's still not made for continuous occupancy, but now there's no means of limited entry and exit. So now people can rush out, run out, right? They can basically crawl out, so you can self rescue. So it's no longer a confined space. But folks, here's the thing. Let's not take it for granted, right? It's still a highly hazardous area. It's still a significant risk area where there could be the potential of flammability, explosivity, oxygen deficiency, or any other significant hazard that may affect quality of life or cease employees' lives altogether. Okay, so so let me go ahead and explain a couple things here while we're here as well. And I just duplicated the slide because I want to get rid of something. I'm going to show you the difference between H2S and I'm going to show you the difference between H2S and gasoline when it comes to LEL, lower explosive limit. and lower flammability limit, okay? And we're also going to talk about oxygen levels as well right now. So I'm just, I think this kind of confused somebody when I did it last time, so I just want to get rid of it. And basically what we're doing is we're going to make one tank gasoline risk. We're going to make the next tank a an H2S risk, okay? So let's get rid of this. Let's see. Okay. All right. And then let's go back to our worksheet first, folks. Okay, so here's our worksheet again, okay, that we were talking about earlier. And if you notice right here in the upper right, this is what we hadn't covered yet. Here are the acceptable atmospheric conditions to either enter this space or to stay in this space, okay? And this is whether we're inside of a confined space or not, but we're going to follow the same principles when we're in a space. First of all, our oxygen level. Our standard oxygen level is either 20.8 or 20.9. In order to be able to enter this tank in general industry or construction, our oxygen level, the least it can be is 19.5, and the most it can be is 23.5. If it's less than 19.5, it could potentially be hazardous to our health because it's oxygen deficient. If it's greater than 23.5, it could be oxygen enriched, which means we may get a little high, and it could also be potentially more flammable or more explosive to the environment if we have enough fuel and if we had a heat or ignition source, okay? It actually becomes more of an accelerant, basically. And then you'll notice that oxygen level on the maritime, the low number is the same, 19.5, but the upper number, right, the enriched area, it stops at 22%. And the reason being is because quarters are often so enclosed and so tight and small in vessels, the conditions can change very rapidly, okay? So therefore, there's a lower threshold in maritime because of the significant risk in the case studies that we've had, as opposed to general industry and construction. And then you have LEL, lower explosive limit. Basically, LEL means lower explosive limit means at what percentage of the room's atmosphere a chemical can become explosive and or flammable, okay? And then a UEL would be upper explosive limit, which is what's the most amount of that concentration of gas it can have before the room is no longer explosive or flammable because now it has not enough oxygen to sustain a fire. And I'm going to show you examples of this in just one moment, folks. And then, of course, making sure our H2S levels are preferably at 0, but no more than 10 parts per million. Some refineries like ExxonMobil, a refinery in Chalmette, Louisiana, and some other Exxon facilities also do 5 parts per million. And you have other refineries that often do 5 parts per million instead of 10 as well as a best practice. And then carbon monoxide, right? CO. Normally we want to stay under 35 or 50 parts per million. Okay. And this is often just dependent in the environment and when OSHA says which one is acceptable. Okay. Usually we don't even get that high, folks. I tell people I work around a lot of generators and light plants as long as there's adequate ventilation, just natural ventilation. I've usually gotten 5, 6, 7 parts per million on CO or carbon monoxide. I've never even gotten close to a 35 or 50 parts per million on a regular basis. Okay. So let me go ahead and bring you to that tank now so we can discuss that tank. Okay, so here you go, folks. Here's a breathable, here's a tank. All right. And what we're going to do is we're going to start with gasoline first, folks. Okay. So so hang with me on this, right? In order to something to explode or to burn, we must complete the fire triangle or the chain reaction, right, within the fire triangle, basically the tetrahedron. So we need 3 things to either start a fire or sustain a fire. We need oxygen, we need fuel, and we need a heat source, okay? So what happens is think about this tank right now, right? Let's say we've been ventilating and it's 100% breathable air. Inside that breathable air, what do we have? And let me bear with me. Let me just go ahead and add this right now. And you'll notice I tend to do this from time to time. So I hope it's not distracting, but it kind of lets me fix it for you and then whoever comes behind you as well. Okay. Let's call it 20.8 oxygen, right? 78.1% nitrogen. and then 1.1 everything else. All other gases. All other gases could be helium, H2S, methane, carbon monoxide, carbon dioxide, you name it. Okay, the list goes on and on and on. So this is what's kept in our 100% breathable air. Okay. So let's see. We can copy this here, so we can copy it into both. Okay. All right, folks. So this is what happens, right? Is in this 100% breathable air, if our LEL and gasoline gets to 1.4% of this 100% breathable air, the room now becomes ignitable, because now we have, excuse me, there we go. Now we have enough oxygen, right? Since we had already breathable air, we have a heat source, and now we have enough fuel. So once it hits that LEL, now the vapors in this room, right, or the gases in this room hit 1.4% on some gases. Some could be 1.2, some are 1.8. This space now becomes ignitable, either flammable or explosive, LFL or LEL, lower explosive limit, lower flammability limit. The only difference is the flash point. Okay, at what temperature will it explode, or will it catch fire? And then the upper explosive limit is 7.2%, meaning that if this space fills up with 7.2% gas vapors now it is no longer flammable. Because what's happened is, if you take 100% breathable air, right, you reduce it by 7.3, we're down to 92.8% breathable air. There's not going to be enough oxygen left in that 92.8% breathable air to sustain a fire. So if the level is too low, if the level is below 1.4, and I'm going to send you some videos, links in the next couple of days to some chemical safety board videos, and you'll see that they talk about this. They call it, below the LEL is called too lean to burn. And too lean to burn means that it has not enough fuel in this mixture, in this room. If it's under 1.4, for this example of gasoline that I used, there's not enough fuel to either ignite or burn this room. Okay, I say this from this space, excuse me. If it gets up to 7.2%, what happens is now there's not enough oxygen. So there's enough fuel, there's a heat source, but there's not enough oxygen to allow an explosion or to sustain a burn or a fire. Okay. And what happens is this, is let's say that for some reason we had a leak in the space, or we evacuated space, right? Once it gets up to 1.4, now we have a LEL hazard, right? Now we have a explosivity and flammability hazard. Once we exceed 7.2, now we're out of it. But this is where another risk comes in. Now we start to evacuate. We put fans in and we start to evacuate this room, right? Let's say this area is 15% gasoline, right? Vapor. Now, all of a sudden, we start to drive down that number, and we start to drive it down. We get back to 10, we get back to 9, 8. When we hit the 7.2, now we're back in the flammability range, trying to get all the way to 0. So we go through the flammability and explosivity range going up, and then we go through the flammability and explosivity range going down. Okay. You're gonna, like I said, I'm gonna have those 2 CSB videos for you, chemical safety board videos, and that's gonna really help you out there. Okay. And then here is your nitrogen. And this is the thing, folks. We can be between 1.4 and 7.2. We can be in this environment, and we can still breathe. We might be a little annoyed, but it's not going to really affect our health as much as it's going to, until it gets significantly higher, as much as it is going to put us at risk of burn or exploding. Okay. Now, let's take H2S, and I have to move that screen I have here. Let's take H2S now, right, folks? Now we take H2S. H2S, if we get to 43,000 parts per million, or 4.3% of this area, of this breathable air, at 4.3%, the room now becomes explosive, okay? LEL, right, or flammable. Once we get up to 46% of this tank, and the breathable air is now down to 54%, now we're no longer explosive, because again, the oxygen. So we need to get to 4.3%. If not, it's too lean to burn, means it doesn't have enough heat source. And once we exceed 46%, now we don't have enough oxygen, so now it's too rich to burn. Okay. Now I will tell you this is that with H2S is such a toxic gas that at 1,000 parts per million, 600 or 1,000 parts per minute, okay, within just a couple minutes, a few minutes, we'll be probably dead. Okay, we'll either have ill effects, passed out, or dead. Now, so that means that, and that's 0.1%, right? That's 1,000 parts per million, which is a 0.1%. So what happens with H2S is that we will never be in a explosive H2S environment unless we're under forced air, unless we're under SCBA or or SAR, supplied air respirator, or like a hose line. But we should always be in a if you remember a couple of weeks ago, we talked about SCBAs. Anytime in toxic gases, we should be in an SCBA. We're in control of our own air because it's on our back. So what happens is we will poison long before we die from explosivity or flammability or just burn up or explode, right? When it comes to H2S. However, gasoline is the opposite. Gasoline, we will burn up or explode long before it poisons us. Okay. So both of them are explosive, right? Both of them are flammable and both of them are toxic. However, what happens is it depends on their composition. Gasoline, we will burn up or blow up long before we are toxic, die of toxicity. H2S, we will die of toxicity long before we burn or blow up. Okay. So when I send you the links to the CSB videos, I'm going to send you at least a couple of them and then 2 confined space videos for you to watch on your own time. That's about an hour videos. Watch them. They're great videos. Okay. And all of this will make sense. If you need to go back to it, like you know, this recording in the next couple of days will be live, or it'll be on YouTube, right? Or whatever video provider we're going to start using. We're kind of talking about moving them over to a lock channel, but you'll always have access to them. So we're looking at just come back to this video. If not, reach out to me. Okay, reach out to me or one of us here, and we'll get you through it. Okay. So that is the difference between LEL and LFL, and then toxicity as well. Okay. All right. So let's go back now, folks. I'm gonna get us back in the book for a few minutes, and I'm gonna get us a break. And about the next 10 or 15 minutes, we're gonna go ahead and take a break out for a few minutes. Okay. All right, so let's go back to the book now. Now, we just talked about oxygen deficiency and enrichment. So we got through 2.1. We got through flammable atmospheres. We talked about LEL, right? We talked about LFL. But let me give you some examples now. Look at your book. Acetylene, butane, propane, hydrogen, methane, natural gas. Those are all examples where we would probably burn up or blow up before we'd be toxic or poisoned, right? Like we said, um, also in there could be H2S as well, but we would probably be poisoned first. And then you see vapor density. And the way I want you to know how vapor density work is this. Is the vapor density, if you read the safety data sheet, right? Let's say on ethanol, right? Or let's say on methane or whatever the case is. If you read the vapor density, if the vapor density is greater than 1.0, it tends to sink. If it's lighter, less than 1.0, like a 0.97, 0.95, 93, 0.89, anything like that, and then it's a little lighter than air and it will tend to rise, okay? So just remember 1.0 or greater. 1.0, it just stays pretty much even in the height of our breathable zone. 1.0 or greater, it tends to settle down. Greater 1.0, it tends to settle. The higher that number, the more it settles, and then vice versa. The less that number, the more it rises. Okay? All right, and then 2.21, measuring flammable atmospheres. We just talked about your LEL and your LFL. You'll also notice that they have a table here in the book on 1.11.4. It's just a little bit harder to understand. That's why I like to go with the example that I just showed you with those 2 tanks, okay? And then toxic atmospheres, we just talked about toxic atmospheres as well, right? And then you'll look on your right-hand side, you'll also see different permissible exposure limits of different toxic gases. Carbon dioxide, carbon monoxide, I told you it's between 35 and 50. They went with a 50, right? H2S, 20 parts per million, which is actually 10 in most industries. There are some industries that are 20 parts per million, Most of them are 10. Industry standards will be either 10 parts per million or 5 parts per million when we must evacuate, when our personal monitor will go off. All right, anybody who's not familiar with a personal monitor, what am I talking about? I'm talking about the Cricket or the personal monitor we'll wear. Let me show you really quickly. So let's go with a single gas meter. Here we go, folks. This is what I'm talking about. We often use a single gas meter like this. Folks, I want you to know this, right? Depending on what our greatest risk is. If we have a single gas meter, we may be reading for oxygen, we may be reading often for CO, and more probable for H2S, okay? And you have other single meters as well. These three tend to be the most common. One thing I want you to know, especially safety, is don't be afraid to ask people, because color doesn't mean a thing. It can be a yellow meter and it can read any of the three. It can be a black meter or orange meter. It can read any of the three, okay? You want to see what it says on the meter and what gas it's reading for. So if we're in an H2S rich, let's say, or risk, right, environment, that meter needs to say H2S. You might have somebody that's got a methane, right, or a oxygen meter, O2, or oxygen, or CO, carbon monoxide meter. So make sure, don't be afraid to look at people's meters from time to time, or instruct them and educate people in the field, right, on how to identify which meter they have to make sure that they have the right meter. Some of these will let you test or let you press the button and buzz it out. Most of them are either 24 or 36 months. Some of them are 24, they'll time out. Usually, most of them, industry standard, will be 24 months. When it gets down to your last month, it'll start counting days. Okay. And once it starts counting days, at the end of those 30 or 31 days, and then it will just time out, and it'll just beep and beep and beep and beep until you get it out of service, until it ultimately dies. Okay. So here's one by Race Systems. You got Altair in here. You got MSA, which is the Altair. You got Gas Tech. You've got a bunch of different brands. Okay. So really, these meters have become so affordable now. You're talking about anywhere from $75 to $200 per meter. Okay. So they've become excessively affordable now. And then let's see a multi-gas meter, right? Somebody who would be reading for oxygen, let's say a safety person, right? Or a group, let's say a foreman, a supervisor, somebody who would be doing the initial sniff in an area, maybe reading with one of these types of meters, okay? Which would be a multi-gas meter. Normally the four gases that we normally read for normally the four gases that we normally read for on a multi-gas meter will be for oxygen and LEL, which we tend to read in percentages, these two. All other toxins we tend to read in parts per million, okay? So there you go. So you see my oxygen 23.5 in percentage, right? My LEL 20% in percentage, okay? My H2S is in parts per million. My 200 is in parts per million for carbon monoxide. That's probably for a maritime environment where they roll on and roll off vehicles off of vessels, because that's the only time you really get to a high number like that in carbon monoxide. Okay, we usually stay 50 parts per million or below, or even 35 parts per million or below. And like I told you, even for me to see 5 and 8% is normally a high number these days. Okay, so just in examples of different meters that are out there, all right, different brands out there as well. Okay, but as you see, most of the pictures and the screens are the same. There's an Altair. One thing I do want you to know about this MSA Altair is you have two different ones. You have a general industry and construction Altair, and you have a mine, an MSHA Altair. The MSHA Altair must be calibrated daily, whereas the MSA, it recommends that you do it once a month for general industry and construction. Okay, but if anybody works in the mining industry, they must be done daily. So it looks like the same meter, folks, except it's MSA Altair, and one almost say MSHA edition or something like that, right? Mine Safety and Health Administration. And like I said, with the MSHA, they're going to have to be calibrated daily. That is a requirement by MSHA. So therefore, the manufacturers of the MSA required as well. Okay. And then, like I said, general industry and construction, it's normally calibrated every 30 days. You're usually bump testing it daily, which basically means you're doing a fresh air calibration in the field just to make sure that you're getting adequate readings, okay, of what your breathable air should be. And calibrating, folks, for anybody who you ever heard the term, you're not readjusting the configuration on the meter. You're just assuring that what you're reading, when you do calibration, you do gas cans, basically, or a docking station. And we're telling it we want it to read 20.8% oxygen. We want it to read 10 parts per million H2S. We want it to read 50 parts per million CO. And we want it to read 10% LEL. And what happens is we hook it up to gas canisters or a docking station. Okay, and I'll show you what that looks like. Let's say a dock station, right? Calibration, let's say. So whenever you or it's called gas cal or gas calibration, this is what I'm talking about. You may go straight to the setup like this, or you may go to some type of docking station like this, where it's all hooked up in a docking station. You dock it, and it's going to automatically test it, okay, and run it through its cycle. Just depending on how much you pay, depending if you have something that's made for the field, or you have something made for the office where you actually have the luxury of having a docking station, okay? So just keep that in mind. This is what your sensors look like, folks, that read your H2S, your oxygen, your carbon monoxide, and your LEL. And if anybody's ever reading things like volatile organic compounds like toluene, benzene, toluene, xylene, items like that, it is a PID or a photoionization detector. And what it looks like is almost like the glass sensor in your smoke detector, kind of. And it can easily double the cost of your sensor. So let me show you one really quickly. Let's see. I'm going to go to Ray Systems. Ray Systems, for anybody who's not familiar, multi-gas meter. Let's do Ray. Anybody who's not familiar with Ray Systems just a few years ago was purchased and bought out by Honeywell. So Honeywell now owns, as many of us know, they own refineries. They also own Ray Systems. They own fall protection like Miller, Sala, DVI are all owned by Honeywell as well now. So is Howard Light Hearing Protection. Okay. Here you go, folks. This is what I'm talking about. These are all your different sensors depending on the gas. It'll say it on the side and it'll be color coded as well. And then this one right here that you see has got a glass. This is a glass eye on this side. And then where it plugs into, this is actually right side. This is upside down right now. These two prongs would actually go down to sit in the sensor, and the bottom of the sensor is glass as well. Okay, so that's what a PID or a photoionization detector looks like, folks. And what it is, it's to pick up volatile organic compounds. Like I said, it'll pick up elements in gasoline, benzene, toluene, xylene, items like that. I tend to tell workers that if it ends in "ene," it's probably mean, so we have to go with it, right, and trust it. Okay, folks. So, and then if you flip the page, we talked about oxygen meters, right? The reason the OSHA standards and the reason NCCER says to read in the order of oxygen, LEL, and toxins is because that is the order of importance. But back in the day, folks, older meters, let's see, original gas meters. There, and I think I've got some in that PowerPoint that I just had, atmospheric. Some of your older meters, let me see, I think I got some in the PowerPoint, and I got a noise one that looks just like it as well. Some of your older meters were actually big, cumbersome meters, and what used to happen with them is that they used to, sorry about that, I don't have it. I'll see if I can find one for you. If not, I'll email it to you. They used to read one gas at a time. They used to read oxygen first, right? And then LEL, and then toxins. And then in toxins, if they got anything, what they'd do is they'd go to a colorimetric tube. If you look, now it's electronic. Look at page 11.7 at your upper right-hand side. That's an electronic colorimetric tube. It could be like that, or it could be like the one that you see on 11.6, which is like the wand, like the handle with the wand. They have some items like that that can read actually for radiation, and then some that can read for volatile organic compounds. And it'll basically tell you what your readings are, not just that you have toluene or benzene or some type of volatile organic compound, but that now you're testing for specific. So let me show you what I'm talking about, right? Let me bring you back, and let's go to let me go to Ultra right now. Ultra Ray. Let's see. Here you go. So this right here is the equivalent of what you see on page 11.7. Just to give you an example, this meter right here, right, will often be used to read toluene, xylene, benzene, one specific gas. And in here right now is that colorimetric tube, that tube that you see on page 11.7. And I'm about to show you what the tubes look like. This is what they look like right here. So depending on the gas, it'll be the color of the box. It'll also tell you what you're reading for, and it'll tell you it only goes one way. It's got some filament in it. The filament will actually change colors, and you used to use it as a cross comparison chart and use it like almost like litmus paper, okay? And then nowadays, what happens is it's all computerized, right? So here's an example. I apologize for the picture being so small. Let me see if I can get you a bigger one. Here we go. So all the different colors you see here are the different gases, and this is one of the manual ones. This is called a pump tech or a pump. And what happens is you'll pull it, put as many clicks on it that each tube tells you. You may be a half a click, one click, a double click. Okay, and what that does is that determines how much airflow is going to come through that tube. And when that tube changes colors, you actually compare it to a chart, kind of like you did probably back in your old science classes back in junior high or middle school or something like that. And that's let's see, color tubes, and that's how you would measure it. Okay, and then color metric tubes. All right, folks, give me about 5 minutes. I'm gonna get us to a break. All right, I know this is going a little long, but there's a lot of information here. And then what'll happen, like I said, it'll give you a cross comparison chart. I was looking for the chart, and you basically just compare it until you get to the closest color, and the closest color will tell you basically what your concentration is. But what also does it is that ultra ray I just showed you, that single gas meter, will do it like this, or the one that you see in the book that's an electronic one as well. Okay. All right, great, folks. Okay, so we talked about the roles and responsibilities of the entrance attendants and supervisors. What I am going to ask you to do is during the break, let's see, I'm going to leave this page up during the break, which is the entrance attendants and supervisors. And basically, as you see, right, look at the number one responsibility in everybody, knowing the hazards and what can go wrong, right? The entrance, also properly using their PPE and testing equipment, communication and ventilation. Communicate with the attendant as needed. We kind of read through these with the standard earlier when I showed you. Using hand signals, air horn. Let me tell you what the rope method or the oath method is. Basically, rope and oath method, divers used to use it all the time before. And what happens with the oath method, right, is that it's OATH, it stands for okay, away. Let's see. Okay, away, to and from. So they used to use, let's say, a rope, right, or some type of line. And what happens is when you pull it, when you pull the rope, O means you're okay. A means you're going away. So the attendant should give you some extra slack and rope. Never the airline, folks. Okay, it'll be a separate rope. They give you some slack. You pull it 3 times, it's 2. We're coming to you, so they start pulling up slack, and then 4 times is help. Okay, so the entrant or the attendant, either one of them pulls once, it's hey, I'm okay, or are you okay, or yes, we're okay, right? We're going away from you. They may confirm pulling twice. You're going away, and then pull twice, right? Yes, we're going away. 3, we're coming to you. The attendant starts pulling up the slack. So if anything happens and you have to pull 4 times, and then you still the line is a little taut, and then 4, of course, is help, right? The attendant may verify 4 help, and then the entrance may again pull 4 and say yes, we need help. And that's when they don't have audio ability to. Maybe they don't have radios. Maybe it's an intrinsically safe where there's an environmental hazard, whatever the case is, or explosivity hazard. Okay. And then you see here again for the attendant. And I'm sorry. And then exiting the area as quickly as possible, right? And then you see attendant responsibilities, the same thing, right? Knowing the hazards, being aware of the behavioral effects for the entrance. Hey, are they giddy? Are they serious? Do they look tired, fatigued? Maybe they're not normally giddy and now they are. Maybe they're a little high, right? Maybe they're normally giddy and now they're not. Is it heat or are they being toxic, right? Are they just serious? knowing how many people are in the space at all times, being able to basically look at your confined space log and being able to, within a reasonable amount of time, basically seconds, tell me how many people are in the space. Okay, never enter into space, maintaining communication at all times inside and outside the tank, monitoring activity inside and outside the tank at all times for any potential hazards, calling and summoning for rescue when necessary, warning and notifying others, right? Any unauthorized entrance, also performing non-entry rescue, basically first aid CPR outside the space, never inside the space, unless they're relieved of their duties and they become a entrant rescuer, and then performing no other duty other than hole watch or fire watch, or excuse me, hole watch. You don't enter the tank. You're not an attendant. You're not an entrant. You're an attendant unless you're relieved of your duty. You don't have to go for it. You don't go get equipment. You don't go to the bathroom, right? You keep monitoring that space. And then you see your supervisory responsibilities, knowing the hazards, what can go wrong, verifying any entries on the permit for air quality, atmospheric testing, terminating the permit upon completion, verifying that rescue services are available if it's a confined space entry, removing any unauthorized people from the permit required confined space, and also determining when any requirements are responsibilities are going to be transferred over. Okay, so let me show you two things, folks, and then we're going to break out for about 12 to 13 minutes. So let me go back to this PowerPoint, this tripod retrieval right here. Let me go to it again. Right here, tripod retrieval. I thought I had a better picture of it. Let's see. Okay, maybe I don't. Might be the only one I have. Okay, tripod retrieval, folks. A tripod has to be furnished, and let me bring you to the standard, folks. Okay, so let's go back to 1910. That's what I'm doing. I'm going back to Google, and I'm going back to 1910 146. And the words I'm going to search is mechanical retrieval. And like I said, folks, I do a lot of standard searches, right? Get a lot of calls for clients that need some subject matter work done. So let me go ahead and pull this for you. Let's say 1910, right? 146. We're going back to the same standard. Basically, if you have any permit required confined space in your workplace and you have a vertical entry, here you go right here, folks. A mechanical device right here. A mechanical device shall be available to retrieve personnel from vertical type permitted spaces more than 5 feet deep. So that means that even if you don't have a rescue team on site, because they're not required to be on site, but they are required to be accessible, right? Within reasonable time, probably getting there within 3 to 6 minutes, basically. But even if you don't have a rescue team on site and you have one available, you still have to have a vertical retrieval system, basically a tripod, a mechanical device on site. Okay, so there's your standard, folks. If anybody needs it, it's 1910 K3 Roman numeral 2. Okay, and then the only thing I'm gonna leave you with is this, folks, and you'll see this in the video, is ventilation. Okay, if you look at in lockout, tagout, and tools, right, and equipment. If you look at pages 1110 and 1111, it's basically ventilating. We want to force air in. We want to push air in and let it ventilate out by itself. If it's underground, we never want to extract air from the space down below, because we don't know what we're pulling out of the walls. Okay, we basically want to blow fresh air in with a blower and a hose, and then it will automatically just push any type of hopefully hazardous air out, and of course do our continuous monitoring. Okay, when you see the videos that I'm going to send you, you'll see that one of them says never extract, never do negative ventilation, right? Never extract air out of a space where you don't know what's on the other side of the walls or the other side of the ground of the soil. Okay, so that's why underground we never extract. We push, and there's nothing wrong with extracting out of a above ground storage tank, but what we do want to do is also furnish air as well. Okay, so at that point we'd do positive and negatives. We'd be pushing in and would be extracting out at the same time. Okay, folks, so let's do this. Look, I apologize for going a little long. I was just trying to get us out of this 11. And when we come back from the break, we're going to get into 12, and just take a look at those last those pictures in the last 2 or 3 pages of ventilation. Okay, and let's do this. I'm going to give you a few extra minutes because we did that. So let's go ahead and we'll reconvene at 8:05. So that's about 13 minutes. Let me make sure I got that right. Yeah, 8:05. That gives us about 14 minutes. Okay, you can look at those 2 pages, and then take a break. We will jump back in at that time, and then we will get through safety meetings, which is section 12. Okay. Thank you, folks. I'll see you in about 15 minutes. I'm going to leave that page up that I had earlier of the confined space worksheet that we have, just in case you wanted to take a peek at it as well. Okay. Thank you. Okay, folks, so we are back. We're going to go ahead and cover now safety meetings. It is module 12, and it's page 12.1. So give me 1 second. Let me go ahead and get out of this for 1 second and go back. I almost ended the training. Sorry about that. Let's see. Okay, folks, so here we go, right? We're at module 12.1. If anybody looked ahead, you'll see that this is a very short module. So I knew we were going to have to front load the work earlier. I just didn't think we were going to push that hard, and the break was going to be delayed a little bit. So again, I apologize for that if anybody had timed that breakout, okay? Just let's go ahead and talk about a few things. All right, let's talk about, and what are we talking about now? We're talking about holding safety meetings, right? Remember this, folks, that one of your evaluations will be safety meetings as well. It'll be to hold a little 3 to 5 minute safety meeting. We've got information already on confined spaces, excavations. We'll be glad to work with whomever needs any help, or if you want to pick your own topic, you're welcome to. Really, it's what you're comfortable with, folks, okay? So we can give you a topic if you want. If not, if you want to pick one, that's fine. And if you want some material to review, I tell everybody, just grab a fact sheet from OSHA, right? Just grab one handout. It's 3 to 5 minutes. And don't read it, right? You read it over and over and over again, and then just tell me or tell us what we need to know about it. What's basically going to keep us safe in the workplace, right? What hazards are we looking for? So also, I'm going to go ahead and throw this out there, folks. And if this was a live class, if we were in a classroom, I would have easily done this, right? Easiest way to start a training is like this. I do a lot of training for University of Texas and for Mid-South for trainers, for outreach trainers. And then I do a lot of train-to-trainer for fall protection, confined space, hot work. And this is something that I'll definitely recommend to everyone, is try to start your training off with either something that is thought-provoking or a question. So let me give you an example. Let's say we just came off of confined spaces, right? And I turn around and say, who's ever worked in a confined space before? So of course people raise their hand, right? So let's say 4 or 5 of you raise your hand, turn around and start pointing around the room. And I may point in general or specific and be like, give me an example of a confined space that you worked in. So therefore, you can kind of go ahead and give me examples of confined spaces that you've worked in, okay? So, what hazards were you concerned about? What hazards were you trained on, right? Same thing. Who's ever worked on a scaffold before, folks? Okay, great. Let me ask you, give me some examples of a way we can get hurt on a scaffold. Okay, good. All right, give me some examples of ways that we can, safe practices that we can exercise to make sure that we don't get hurt on that scaffold. So what I'm basically doing during my safety meeting or training is I'm asking questions and getting the participants to give me the answers. So I think for a very long time, y'all, and this is one of the only challenges for me with these webinars is that I'm telling a lot, right? I'm giving you the information. I'm not in the position to ask, especially considering that most of you are on smart devices and then you can't chime back. It's not so easy just to type back in and chime back. But we're so used to telling, maybe we need to ask. Instead of telling employees how not to get hurt on the scaffold today, how about asking them, give me some give me some examples of practices that we can do or things that we need to watch out for so that we don't fall on that scaffold or off that scaffold today. Okay. So just keep that in mind, folks. So we have both, right? Formal meetings often done about once a month. We also know our tailgate meetings are done usually daily now, hopefully daily, at least weekly, if not. Okay. And different things that we can talk about, right? Suggested safety meeting topics, recent accidents or near misses on our work site. Perfect teachable moment, right? Also, what about OSHA fatal facts? Or for anybody who's not familiar, folks, the OSHA Focus 4, Fatal 4. I've used this over and over and over again. Let me give you an example. I'm going back to OSHA, right? I'm going back to Google, and I'm looking up OSHA. Let's see, fatal focus 4. Okay, right here, fatal 4 focus 4. Okay, and what this is, folks, this is OSHA's 4 greatest hazards in a construction site. Which here you go. This accounts for over half of the fatalities, closer to about 60%. It used to be said that it calculated to about 70 or 80, and I'd say that that's still potentially true. Falls, right? Normally fall into a lower surface. Could be same surface fall, but it's normally a person falling to a lower surface. Second of all would be being caught in, under, or between something in the tracks of an excavator, uh, two converging walls, okay, being crushed by a concrete pier, anything like that, right? So, pinch points, right? Anything that's pinch points, whether it's physical or mechanical, or even it could even be atmospheric, things like a trench, okay, particulate, right? Silos. It could also be hazardous gases, where to the point to where we become asphyxiated, right, or toxically poisoned, all right, and trapped by fire, possibly. The next one is being struck by something, a flying projectile, a piece of equipment or material that failed, being struck by a fist, a bullet, being struck by a motor vehicle or a powered industrial truck, right? Some kind of skid steer, a belly dump truck, um, uh, uh, backhoe, trackhoe, crane, okay, you name it, right? And then last of all, electrocution, right? We can be burned, we can be electrocuted, we can fall, we can be shocked, we can be injured from arc flash, and then of course explosions as well, right? So, so many different ways that we can be harmed by electricity as well. So there's a perfect example, fatal facts, right? Or your OSHA focus or fatal 4. It could also be Department of Energy. If you go to Department of Energy, this is the easiest thing to do. um, Let me see if I can pull it up like this. I think it's DOE lessons learned. Okay, and what it'll do is you get to Department of Energy lessons learned. Now, normally this is around, could be around compressed gases, but it's normally around electricity or nuclear. And you can go in and start looking for different type of safety topics. Okay, on lessons learned as well. Okay, significant hazards that have happened. Right, so that's a government agency as well. So you can just go in there and basically it's a mishaps. It's a case study, is what it is. You can pick a story and do it. You can use your OSHA fact sheets as well. Okay, the publications. So let me take you to that again. So you go to Google, right? I'm sorry, let's go to OSHA, OSHA.gov, OSHA.gov. And now I'm going to, right here, I'm going to type in publications. This top one right here, publications. We did this tonight's Tuesday. It must have been Thursday. Okay. And let's say I'm going to do aerial lifts, right? Grab a fact sheet, grab a quick card. These are the two easiest ones, a fact sheet and a quick card. It's usually 1 to 2 pages. Here you go, aerial lifts, right? 1 page, 2 pages, okay? Different hazards, how we need to practice, even has OSHA standard numbers. I wouldn't use OSHA standard numbers though, and some type of just tailgate or even small safety meeting, okay? Unless it's supervisors. But there's the standard numbers that we're violating as well, okay? ANSI and OSHA. So there's an example of a fact sheet, okay? Quick card's even shorter than that. Where's my quick card? Here we go. HTML, folks, right here. This HTML prints horribly. I would not use an HTML, okay? I would use the OSHA fact sheets or quick cards, and I like these a whole lot better. There you go. Normally 1 page, if not 2. The English, right? And then there's your Spanish one if you train in Spanish as well, okay? Okay, so let's get out of that. It could be accident analysis. It could be upcoming jobs and tasks. Maybe new training that we need to either make sure employees are brushed up on. It could be a good opportunity to talk about training that's going to be coming down the pipe. Okay, so it could be any future training, past training, near misses, incidents that have happened. Okay, observations. Also, national interest topics like National Fire Prevention Week, National Fall Protection Week, Safety Stand Down, which is going to be in May. All right, it could be OSHA training requirements, right? We have to be trained on the safety data sheets. We have to be trained on powered industrial trucks. Maybe not doing the training at that moment, but at least discussing the necessity for it, finding out who's trained, who's not, who still needs to be trained, okay? In order to find our gaps, right? And that helps us perform our gap analysis to figure out who's missing what, because sometimes we think that they're trained, but our employees haven't been adequately trained in that particular hazard or topic. And then also results from safety audits, inspections, and observations as well. So it could be the results of what we it could be the results of what we already have seen as trending, right? Where there's significant risk, somebody could have gotten hurt, somebody did get hurt. Okay, if you have a behavioral-based safety observation card program, maybe reviewing them then, right? To go ahead and start hopefully getting some corrections done in your workplace. So just all different ways of incorporating safety and not being same old, same old. Okay. So my biggest thing is let's find the information that's out there instead of reinventing the wheel, folks. A lot of times we're trying to figure out what we're going to train on. Grab a fact sheet, get to know it. My thing is this, folks, is do not grab that fact sheet and start reading off of it. Okay. Imagine, so let me go back to the OSHA publications, right? Let's go back to this aerial fact sheet, right? So, perfect example here, right? If I look at you right now, folks, and I say an aerial lift is any vehicle that's mounted and used to elevate personnel, including extended booms, aerial lifts, articulating booms, vertical towers, and any combination of the above. Aerial lifts have replaced ladders and scaffolding on many job sites due to the mobility and flexibility. They may need to be made of metal, fiberglass, reinforced plastic, and other materials. Okay, so I'm going to stop there because I don't want y'all to hang up on me and get off the line, right? But what we can do is this, right? And say, hey, y'all, as you notice, we usually try not to use a ladder or a scaffold, right? You'll see us using an aerial lift or a boom lift or scissor lift around here, folks. So we're going to go ahead and talk about those hazards, and we're going to go ahead and talk about our pre-start inspection. We're going to talk about make sure that who's been trained and who hasn't, and we're going to talk about doing inspections in our work zones as well, okay? And then we're also going to talk about fall protection and a little bit of safe practices and how we can hopefully better protect ourselves in the workplace and without using these pieces of equipment without being harmed. Okay, you see what I'm saying? So but you got to know the sheet. If you don't know the sheet, or at least most of it, right? I don't expect you to memorize the pre-start inspection checklist. First of all, that's going to come from either here or it's going to come from the manufacturer's inspection list checklist that we must follow anyway in the manual. Okay, so but know enough of the information to get the conversation and the dialogue started, so that we don't lose people from jump. Okay, are you good? Okay, so let's go to 2.1.0, coordinating and conducting safety meetings, right? So safety meetings, right? We got to plan them in advance. You know, we need to plan them in advance. Why? Because we're anticipating significant changes, right? Risk, hazards, or or emphasis that we're going to have to be given to particular hazards. And then we have to consider certain items when we're going to go ahead and pre-plan things like this, right? Um, Meeting site preparations, right? Make sure that all the necessary projectors, pencils, whatever, if it's a cool down tent, okay, if it's in the morning, whatever the case is, make sure we have whatever we want there already if we're using any props or whatever the case may be. Also, meeting time, making sure that we've got the right meeting time where employees are going to be able to adequately make it on time. And then, of course, us also, right, being early, being ready for that meeting as well. Okay. It's not always possible, but if we're telling employees, I mean, y'all saw this webinar. We used to start at 6:15. So many people are struggling to get on at 6:15. I had people waiting at 6:15 to 6:30 or 6 to 6:30. It wasn't fair. Now it's everybody 6:30. You saw me today. What, 6:31, 6:32? We kicked it off, right? So we're trying to do it more and more to kick it off on time because we think it's only fair for the ones that have logged in. Okay. Um, and we know so many of you are catching it after hours now as well, due to life's necessities or work's necessities. Also, the meeting location. Where are we meeting? Is it on site? Is it off site? Make sure it's got adequate light and make sure it's safe, right? Not too cold, not too hot. Meeting materials as well. Do we need any handouts? Are we using any props, right? Also, preparing your presentation. Like I said, walk in, right? Have it ready. Don't be reading, cramming last minute. Let's try to plan ahead if at all possible. Group composition. Who's involved? Is it line employees? Is it supervisors, right? Is it safety personnel? Is it everyone? Um, and then also audience, right? Pet peeves. Like I said, people, a lot of, and I try to control this a lot of times, and I still fall guilty of it. A lot of or finishing, or having a nervous tick. Watching your body language, of course. You see, I just did the right? Because I'm trying to think of examples. Watching your body language as well. Not reading to people, just having a discussion, just perfect examples. And then appropriate topics, right? What's the topic? Is it relative to the type of work that we're doing? If it's not, maybe we need to talk to management and find out why we're doing a topic. Maybe there's a topic that we can better use, that's going to better protect employees, or keep hazards on the brain to where we can more safely work around them. And then, like we said, right, participation and preparation again. So these are just some examples of things that we should do in order to prepare for that meeting. Okay, I tell people you should have 3 to 5 touches with that material before we even talk to somebody about it. And then on that, the more experienced we are, the more we're going to be used to doing it, folks. The more it's the same thing. And this is something that somebody told me this a while back. I think I was teaching like a 4-day confined space. And imagine what we just talked about in an hour and a half, right? Imagine a 4-day confined space. I mean, you're bleeding out the eyeballs by day 2 and 3. Okay. And the person that told me this, I was really appreciative of it. He says, Doug, I'm gonna tell you, he goes, and the good thing I'm gonna give you is that he goes, the education is in the conversation. You don't read to us, you don't tell us, you ask us what we think, give us examples, you give us examples. He said for 3.5 days, we had a continuous 3.5 day dialogue. And you know what? I'm appreciative of that, y'all, because that's what I shoot for, right? And like I said, it's one of those things that the more we work at it, hopefully the more that we can make the material relatable. It doesn't matter how important the material is. It doesn't matter what our agenda is that if our participants cannot relate to what we're saying, our participants do not stay engaged, forget it. We're actually just wasting our time. Okay. We're really just going through the motion in order to be able to check the box to say that we had the training. So just keep that in mind, right? Let's have those conversations. Let's ask those questions. Let's ask for examples, right? When they want to volunteer it, let's see about trying to squeeze that time in and fit in that time as well. And then you'll see here, you'll see the presentation evaluation guide, right? And I remember a few weeks ago when we did the one on presentations, you saw that it was somewhat similar to this evaluation guide as well, right? So title and lessons, right, stated or displayed. Sometimes you talk about this objectives or we state them or the lessons. Sometimes we don't, depending on how much time we have. The more formalized the meeting, the more we should have the title, the more we should have the training objectives of what we want to do, right? What our terminal goal is. Also, motivation being established, right? Lesson being overviewed. That's all part of the introduction. Presentation. Is it appropriate for the level of employees that are there? Is it too basic for most of the employees? Is it too advanced for most of the employees that are there? Were the objectives covered? Presentation, does it follow a logical sequence? We'll probably talk about that on test day, right? Remember this, is that not always do things have to be chronological, but they do have to be logical. If they're not logical, it doesn't matter if they're chronological. It doesn't matter what happened first if the employee doesn't understand, if the worker doesn't understand. So we have to keep things, although chronological is important, right? We do want to maintain as much quality control of our story that we're telling, but most importantly is going to be that it's in logical order, right? Also, we're using any type of visual aids, right? If so, a projector, a monitor, let's say, a prop, right? Let's say one of these gas techs or a piece of, rebar that somebody almost fell and impalement hazard, right? Or let's say a harness that we pull out for training or a yo-yo. So are we properly using the props, right? Are we illustrating the point? Is it visible to everyone? If the group is rather large, maybe we want to be a little bit more elevated. Maybe we want to do smaller workshops and maybe have multiple presenters, okay? Or if it's like a look-see or show and tell. Out of sight when not in use, right? When you're done with the prop, get rid of it, move it, get it out of, and that's sometimes you're going to leave it in place, especially if you're going to continue referring back to it. Use methods suggested in the guide, right? Also, questioning techniques, different types of ask questions, right? Sufficient number. Are we asking enough questions for engagement? Are they focused attention? Uh, are they creating discussion? One thing I tell people, and I had a trainer around here, and it was really difficult for me to kind of work with him because he had this thing where he constantly asked an employee, let's say Jim Smith and Betty White, right? He'd say, Jim, give me an example of the three things that make up a confined space. Betty, tell me the four things that make that confined space permit required. Well, not all employees know that, folks. So let's not put them on the spot, right? Maybe ask a team, a whole cluster of employees or groups, right? Hey, one of y'all over there, can y'all give me an example of one of the things that are confined space of the three, right? Or the whole group. Hey, somebody give me an example of there's three things that make a confined space. Go ahead, call them out to me. Let's go through them, right? And then we recap them, and hopefully employees start remembering them. Okay. So, of course, questioning, right, relating the information to applications as well, adapting it to the level of participants, like we said. We want to again summarize whatever key points, right? So if we're talking about our fall protection, at the end we're going to say, all right, folks, so we talked about the fall protection, we talked about how our harnesses work, how they're made to keep us safe. So in summarizing, let's make sure we do our daily inspections, right? Let's follow the instructions that come in a little booklet that come on your harness. All right, so good. Okay, so y'all give me some examples of, again, of things that we might be pulling a harness out of service, guys. Ladies and gentlemen, right? And we go through it. Also, pointing out the benefits to participants. What's the benefits? Not being hung up there, right? Not being injured. Okay, so a lot of times it's what's in it for me and for the employee. So we're trying to show what the benefit is to the employee. Instructor qualities, right? The more we practice it, the better we'll be. So definitely work on it, right? Tweak it, exercise it. Look, I'm going to tell you, folks, I teach a lot of OSHA standards classes. One of them, I bombed. I bombed like you wouldn't believe 4 years ago. Now it's one of my strongest classes. Why? Because I continued working it. And I also realized it's the OSHA 510 for anybody who has taken it or anybody who knows of it. And that was about 4 years ago. Well, I'll tell you what, over the last three and a half years, I worked it and I worked it and I worked it to the point to where I realized how important of a class it is, how much people need it, right? How much direction it gives us as safety professionals going in or already being in the industry. And I just worked it and continue. It's always a work in progress for me, that course. It's good. And I still work as hard as I work my tail off to try to make it as relatable and as relatable as possible and as palatable as possible as well. Okay, and knowledgeable. Also, gestures and mannerisms, right? Eye contact. When we talk to the group, talking to the group, do things like, making sure that we do make that eye contact as much as possible, but not just during training. What about before or after? If I don't have the decency to look at somebody before and after, do they really care that I look at them during my presentation? Right? Knowledge, right? What's our level of knowledge? What about our voice? I had another group down in Porter, Texas, I think it was, and I was doing some work at a shipyard, and they were like, Doug, you change your tone, you go low, you go deep, you speak fast, and when it's serious, you get your voice deep and you go slow. And I really didn't even realize I was doing it, y'all. I just kind of did it, right? So, let's take the good and the bad. People critique stuff that we do good, great. People critique stuff and didn't really care for it. Well, let's try to work some of that stuff out of our presentations, right? So it's just a constant evolution. Also, having that professional attitude, right? Don't do as I say, do as I do. And I'm not telling you have to follow it. I'm going to follow it too. It's a sign of a good leader. It's a sign of a sign of leadership. It's a sign of responsibility, right? Respecting the standards or the rules, whatever you want to call them, and following them and being that example. Enthusiasm for the subject. We gotta like it. Let me tell you, there's a few subjects before excavations I wasn't crazy about. Now I like it. But showing that enthusiasm. If not, let's not teach it. Have somebody else teach it that has more enthusiasm and more knowledge. I can tell you this.
Usually the only reason we're not enthused about training or explaining something is because we don't know it that well ourselves. Maybe we're better off bringing in, and we need to know in safety when to tap out. We need to know when to say, I can't do this. I'm going to bring somebody else that's better prepared, and then you're going to learn from that person as well, right? Or I am. And then, of course, overall comments, right? Complete all material, um, follow, all safety procedures as well. And then any additional comments, right? So basically, there's your 2-page evaluation guide that maybe you want to build your own training to, but not only that, use a similar type of evaluation form to have your participants evaluate you, maybe not in a 15-minute tailgate safety meeting, right? But let's say it's an all day or half a day training, put out the evaluation, see what they got to say. Right? Don't get insulted. And I'm gonna tell you, I'm one of those. I get insulted. I tell people, you know what you call constructive criticism? Criticism. I don't like it, but I also understand this, y'all. I also understand that the more I do it, right, and the more I listen to people who are listening and are critiquing, and the more I work with it, the better it'll make me, the more effective it'll make me. Okay. And the more tolerable I'll be to everybody else, and the easier it'll make my job on myself as well. Okay. All right, good. So let's go ahead and move on. Let's go ahead and you'll see on the right hand side, things that we need to know, right? Where, right? What's the number of employees? What's the number of meetings per year? Are we doing one a week, once a month? Let's have an idea so we can start mapping out what we want to do. And then, of course, we know things certain times will come up from time to time as well, right? Near misses, maybe emphasis programs, whatever the case may be. Average hourly wage rate, all right, including fringe benefits, maybe knowing what the hourly wage rate is. In our industry, we pretty much know who's in the field, how much people are making, foremen, supervisors, operators, crane operators. We tend to know a ballpark safety, a ballpark figure. Okay, so I think we kind of know that already. Also, the average length of time in the meeting. I tell people, tell me what I need the budget for. I can teach something in 20 minutes. I can teach it in 2 hours. I can teach it in 2 days, right? But the time limit is going to often tell me how in depth we're going to go into that training material. All right, or how much background we're going to get. So, example down below, right, of what we're talking about. 25 employees attend 12 one-hour meetings, right? One per month, basically, right? The average hourly cost per employee is $27 an hour. You know what that's telling me? That's telling me it's a pretty decent paying company. If the average is $27 an hour, I'd say that we're pretty much in good shape, salary-wise with this company, okay? So, and it's a cost of safety equation, right? Because what are we doing? We're calculating how many employees, the number of meetings per year, okay, the average hourly rate, and what it's doing is it's telling us how much money the company is paying for us just to sit in these safety meetings. And look, and look at an example here: 25 employees, right? $8,000 a year. What happens when we have 200 employees? All right, and it's a monthly meeting. Now you're looking at that number is probably what, I don't know, 70, 65, $70,000. You're talking about a significant amount of money that the company is spending for us to sit in training and training. So you know what? Let's give them their money's worth. Right? Let's take our training to the next level. Let's improve our training. If we're intimidated by it, let's figure out how to get past it. Right? If we need help, let's get some help. Right? Maybe we need to play co-pilot on this one. Maybe we need to bring somebody in and do a panel training, right? Where somebody can answer the more technical questions. So, we have so many different options there, right? Okay. And then and and then in addition to that, uh, let's talk about toolbox or tailgate safety talks, right? We know they're going to be short. They're normally 5 minutes, 10 minutes, 15 minutes max, right? Usually once a week. If it's once a week, we're probably looking at about 15 minutes, maybe a little bit longer. If we're looking at once a day, we might be looking at 5 to 8 minutes in a day, right? So just depending. Do we need any type of audio also? Keep that in mind, right? So, so like we said, some are held daily, some are held weekly, just depending on the company, right? And they should always be conducted when certain conditions exist, right? If the certain job hasn't been performed for some time, hey, let's, before we go do that task, let's have a little safety meeting about it. Also, new employees, right? Join the crew. If we have a significant amount of newer employees, maybe it's time to have it. It'll put some of the older employees and new employees on the same page. A task or the location poses specific hazards, right? It might be that we're working more on elevated work surfaces, or maybe sleet's moving in, and now we have to worry about sleet on the scaffolds or ice. High volume, high traffic, high speed traffic, right? Maybe we're working around highway construction, or where a lot of larger vehicles or over the road vehicles are going to be involved, or dump trucks and skid steers and other road earth moving equipment, let's say. Very limited sight distance, right? An approach to a work zone. Maybe there are some blind spots. Maybe we know we're going to be working on foggy conditions. Let's talk about it. All right. Areas known for high accident rates. So what are we talking about? Easy, easy. Your focus for, right? Your falls, your caught bys, your struck bys, and your electrical hazards. And then in addition to that, also subsequent substantial changes in the work conditions or the work environment, right? Recent accident that maybe somebody got hurt, whether it's with our company or somebody else. You know what we call that? We all know a stand down, right? That's a stand down training is what it is. So let's just talk about it, right? Um, in addition to that, near misses, incident reports, right? Also. And of course, being able to maintain the injured or ill's privacy, right? Making sure that we know that we're not going to violate the right to their medical privacy. And then supervisor feels employees are becoming lax in safety, right? When we start seeing complacency, maybe. So safety talk preparation, right? What are we talking about? Well, hey, let's start with a review of safe and recent safe work and practices, right? Let's present short talks and topics that are related to the current and upcoming work. Let's limit the talks to 10 to 15 minutes, right? I think five is a little too little, but I think 10 to 15 is a good amount of time for a weekly meeting or daily. A daily meeting, I'd say maybe 5 to 8, no more than 10, right? Weekly meeting, 10 to 15 probably. After that, we may start losing employees, and are they standing? Are they sitting? All this is going to come into play as well. Encourage employee participation, right? Let's get some involvement. Maybe make it a little bit fun. This is what I say is, if we can make our training anything, right? If I can make this a tailgate safety meeting, a conference, I do conference speaking as well. If I can make it entertaining, engaging, all right, and educational, if I can make it all three of those, right? Entertaining, engaging, and educational, hopefully that training will be effective and will help our safety culture, okay? And will help prevent injuries and illnesses, or fatality in the workplace. Okay. Oh, using open-ended questions like we talked about, instead of asking, it's not, oh, has anybody worked on a scaffold? Because we know it's going to be yes, right? But has anybody ever heard of let's say of a boatswain chair, right? It may be an answer that we may not get a yes in. So, ask basic questions where we're going to get some yeses, and then it's, what type of scaffold did you work on? Tell me where you worked on it. How high? What's the highest you've ever been, right? Easy to answer, easy to use questions. Okay. Um, in addition to that is also review recent near misses and workplace injuries. Okay. Yeah. Also TVs. Thank you, Cornelius. So also including like monitors or TVs or projectors. Okay. So great call, Cornelius. Thank you very much, because I wasn't even covering that. So you see that more and more these days, right? Um, you see more and more facilities now, including projectors, right? Including monitors. So absolutely. And then great call, Cornelius. And then props as well, right? So all that is really good because that whole audiovisual helps keep employees engaged, right? Pull out, let me give you an example. If you do wire rope, right? If you do slings, in a safety meeting, even when employees that don't work around the slings, and if that's what you're talking about, that's what you're talking about. Pull out some synthetic slings, right? Pull out some wire rope slings. Okay, whatever you can pull out, and show them how the anatomy, show them how it's built, right? Somebody that's qualified, right, and that knows enough about it, show them how the webbing goes, how the stitching goes, right? Show them what a strand is, show them what the wires are, show them that it's a right lay sling or a left lay sling, right? So these are all items that are really great to go ahead and use as teachable tools, right? A teachable moment. And then look at page 12.6, right? Your self-evaluation. I'll give you 1 second to look at that, and then we'll talk about it, okay? Okay, so let's talk about it, okay? Okay. Your topic, right? Presented topics related to the work, right? That's being done on site. Do you use other resources, right? To look up relevant topics, NIOSH, OSHA, ECLOSH, right? The Center for Disease Control, that's CDC. Center for Disease Control, just so you know, and NIOSH pretty much are the same thing, okay? They both do a health, and they talk a lot about respirators and bloodborne pathogens, noise, items like that, okay? Also, preparedness, right? Before each safety meeting, right? We want to make sure we're prepared, that we inspect the job site like we talked about, right? Read over the materials, know our material, look up any terms or concepts that we don't understand. Look, folks, let me tell you, there's nothing wrong with saying we don't know, but we can't keep on talking about topics and we don't know what it is. And then the biggest thing is, more than that, is to make sure that the biggest thing on top of that is to make sure that we acknowledge we don't know it, be willing to find the answer, and follow up on that answer. Okay. And you know what? I'll be honest with you. I think that's what's really strengthened me up a lot. And I still have a long way to go in this industry. We all do, right? But it's the fact that I look up the information when somebody asks me for it, because I don't want to fail. And usually I try to look it up there. I'm usually quick about looking up information, because if I leave, I might not follow up with them. And the more frequently that I don't follow up with people, the more credibility that I lose. Also, making sure that we're familiar with any laws or regulations, right? Make sure that we're not stating that, we can do something and we're violating some type of law or standard. Um, Review reports from recent accidents. Get that involvement, like we said, right? Begin like real life examples, open ended questions, encourage people to participate, maybe invite crews to ask a question, right? Look, I can tell you this is that if we talk, and the last 20%, we were asking for questions, too late. Most people have checked out already, folks. If we're not engaging and encouraging questions from jump or from the early onset, we are going to probably lose most of our people. By the time we get to the end, it's just a formality. So let's try to keep our questions rolling throughout the whole topic, and you'll notice that it'll make our training a lot easier, okay? When we do a little 3 to 5 minute evaluation, we'll talk about it first, right? I'll give you some examples. I'll get you thrown back at me or whoever's doing your evaluations, right? Whether you may be testing and evaluated individually, you may be in a group, depending what city you're in, okay? Whether you're New Orleans, Houston, Austin, San Antonio, probably be with a couple people. Other cities, it may just be you, okay? Um, so just some examples, right? Allowing time at the end for a few more questions, but like I said, don't let them all back up to the end. But don't get thrown off your training either, right? That's another thing. We have to kind of stick, and we know we have to cover the material that we have to cover. Ask the crew for feedback, right? Involve the crew in preparing for the meeting in the future. A lot of times I do that. I go to crane and riggers and say, hey guys, I'm going to have a training meeting. Can I use y'all? Would one of y'all mind doing a little bit of speaking? Me asking you some questions? I did that with load charts. We did a crane and rigging safety one time. I brought the operators and the riggers into it, and they started teaching everybody else why it's so dangerous to be within the swing radius of a crane, right? And you know what? I think they took it much better from their own people than they took it from me. Okay. Also, like we said, following up, right? Looking into complaints, concerns, reporting back to employees at the next meeting, which maybe what you discovered. Um, and then, like we said, right, also protecting our credibility, like we just talked about, right? Using ourselves as a safety example, inviting crew members, right, to come with you anytime on safety problems, as long as it's within reason, right? And they're allowed to be in that area. And then encourage and reward safe work practices, those attaboy programs, caught doing right, right? I think all those are really, really great, So I think those are all really great examples. Um, and then also, if you look at the right hand side, look at 3.2.0, right? The five P's of successful safety talks. What are we going to look at? Prepare, right? We've continuously talked about preparing. Pinpoint, be specific. If we're talking about aerial lifts and scissor lifts, talk about aerial lifts and scissor lifts. If we're talking about fall protection, let's talk about fall protection. I do a lot of project management, right? And we're writing a training program for project management exam. And one of the key terms in there is scope and scope creep. What is scope? You stay on target, right? What's scope creep? It starts getting out of your scope. Next thing you know, you don't even know where you are anymore. Okay. Or you lost your time and either you're rushing it at the end or you didn't cover the material that you needed to cover. Of course, personalizing the story, right? Personalizing to ourselves, possibly people that may have been affected in the workplace, right? You're giving a story, whatever the case is, maybe pull somebody up and let them, if they're willing to share their story or their experience or their near miss, all right. And then picture, right? Create that mental picture. Like Cornelia said, put it on the monitors, right? Put it on the screens, put handouts. I tell you this, folks, you'll see that when we do the tests are black and white, the evaluations are all in color. Okay. Some of them are black and white, but color letterhead. We're one of these. They tell me that I love to kill trees and I love to kill toner, and ink. But, I'm one of these that I think that you want to lose my attention quickly, continue giving me black and white. Okay. And if I'm going to save a few more cents, per copy or per dozen copies, what value am I putting on safety that I won't even print the things in color? I'm not saying the occasional thing doesn't have to be in black and white, but it can't all be in black and white. Okay. And then also prescribe, right? You know, in closing that safety talk, right? What are we going to tell the workers, right? What we expect. What's the expectation in this workplace, right? What is acceptable? What is not acceptable? So what we're basically doing is we're prescribing or we're recapping, right? So perfect example. And then of course, record keeping, right? We want to make sure that as far as record keeping, we may be talking about the injury and illnesses, which you'll see we're going to have that coming up in one of the next few chapters. And we may be talking about a recordable incident rate, right? Our lost time. We may be talking about, X amount of hours or days or months or years without a lost time incident, right? Without a recordable incident. Maybe explain to employees what a recordable is, right? Is a good example too, especially newer employees. Okay. And then, and monitoring those incident rates, right? That's one form of record keeping. If you look at 12.8, which is our last page for the night, which is record keeping of the list of attendees or employees that attended the training. So making sure that we go ahead and memorialize, right? We record who was at that training, have them print, have them sign in. So that way later, we can make sure that we have accountability if we're continuously missing employees or the same employees. Even worse, if we're missing supervisors, is the job so important that the employees or the supervisors are doing that they're not making these meetings? These meetings should at a minimum be highly encouraged. And in my opinion, they should be mandatory. And if they have to be held at different times to accommodate everyone's schedule, they have to be held at different times to accommodate everyone's schedule. If not, if we have 2/3 or 3/4 of the population, right, that's in training and the other ones aren't, I think it starts to chip away at the integrity and the value of our training. So, I'm one of these proponents that, hey, if you're off of work that day, whatever, okay, you missed. Do we need to catch up on it? If it's constantly the same people or the same group missing training, no, it's not acceptable as far as I'm concerned. It's not acceptable on the employees and the supervision's part, and it's absolutely not acceptable on the company's part. Okay. Well, folks, look, that is everything I got. We closed out modules 12, 11, and 12. When we come back on next Tuesday, we're going to be talking about the accident investigation process and then data collecting. Okay, so we're going to knock out 13 and 14 in one shot next week. We're probably going to go long on the first half again, and then we're going to probably go short on the second half. It just seems to be the way that the training material is going to kind of pan out. and then we'll decide if we're going to go any further as well. Okay. Also, folks, I'll tell you what we're doing is actually this week we're actually recording sessions from the back to the front, so that way we'll have extra sessions recorded as well. For any of you who are looking to move forward, do me a favor, folks, if you wouldn't mind, when you watch this video or if you're on the line tonight, if you are moving faster and you're going to be anticipating not being on next week, most of you I know who's not on, but anybody who's on tonight or was on last week, if you still anticipate on being on next week, just if you don't, just shoot me a text and let me know, because that way we're kind of hustling to get the modules up a little bit faster for everybody. Okay. So, hey, y'all, I want to thank y'all. It's about 10 minutes till. I want to get you off the line. If you have any questions, by all means, call me. You know the drill. Call me, text me, email me. Okay. Excuse me. I'm sorry. It's only Tuesday, y'all. I'm losing my track of thought. I'll see you Thursday night. I'll see you in 2 nights. I'm thinking that it was Thursday night, so you can tell where I'm at already, right? So, but great, y'all. Thanks so much for tonight, and I will talk to you all on Thursday. Thank you, folks. I'll leave the webinar open for just the next few minutes, just in case anybody's got any questions, okay?